Continuing on with the section on chapter 1.4, on the last video we worked on solving absolute value equations. Now for this video we'll be talking about inequalities regarding absolute values. So I'm going to be continuing on with the section 16, 18, 20, 22, 24, and 26. For the directions, solve each inequality and write the solution set if the variable is an element of the set of integers. For number 16, absolute value y plus 2 is greater than 7. So much like the regular equations, for absolute values, we're going to have two sides. We want to drop out the absolute value. In order to do that, I need to split this problem up, almost like that. Y plus 2. The original question talks about greater than 7. But we have to talk about the other side as well. So I'm going to include the same direction. And instead of 7, we're going to do the opposite sign. So it's negative 7. By doing so, this allows us to drop the absolute values out. And from here, it's just regular work. Subtract 2 to both sides. This cancels out. Y is greater than 5. And this is negative 9. So on the number line, this part of the equation tells us that y must be less than negative 9. So just put negative 9 here. And it's all values without including negative 9 itself. That satisfies the system, and the same thing with 5. Y is greater than 5. So I'll put a point here for 5. Y is greater than 5, so it shades to the right. And if you want, we can apply a test point. Applying a test point will allow us to make sure that the shaded region is actually the correct answers. So you can put a test point of negative 10, you can put a test point of 6. So going to test negative 10 and 6 because they're in the shaded region. And I need to make sure that the shaded region is actually true. So for negative 10, absolute value of y plus 2 must be greater than 7. So I'm going to substitute. Negative 10 plus 2 is negative 8. And absolute value of 8 is 8. And a is indeed greater than 7. Same thing with 6. Y plus 2 is greater than 7. We're going to plug in 6 in for y. 6 plus 2 is 8. Absolute value of 8 is 8. Is 8 greater than 7? Yes, it is. If that's the case, then we know that this is indeed the correct answer. So y is greater than 5, and it's also less than negative 9. On the next question from the book. Question number 18, absolute value of x minus 3 is less than 4. X minus 3 is less than 4. I'll need to split this up. We have the original first, but then we have the other side as well. Notice by applying both sides allows you to get rid of the absolute value. From here, we're going to add 3 to both sides. Cancels out. X is less than 1, or 7, 4, 5, 6, 7. Negative 4 plus 3 is negative 1. So all numbers between negative 1 and 7. The left side, x is greater than negative 1. So it doesn't have the equal sign, so it's going to be shaded to the right. And on the right side, x is less than 7. It's all values left from 7. So if you can see, there's a common shaded region between these two. So in this case, we could just apply a test point that agrees with numbers greater than -1 but is less than 7. So I'm going to test 0. So to revise, x minus 3 is less than 4. 0 minus 3 is less than 4. 0 minus 3 is -3. Absolute value of -3 is 3, and 3 is indeed less than 4. So if that's the case, x is less than 7, but it's greater than -1 is your answer. On to the next question. Question number 20, absolute value of 2b minus 7 is greater than or less equal to 9. Same routine. I'm going to split this up so that we have two sides. Not only do we have the greater than or equal to 9, but we also have the other side as well. Notice how the signs are in the same direction. And I need to incorporate the negative part of the original question. From here, it's just adding 7 to both sides. -9 plus 7 is -2. Nine plus 7 is 16. This is 2 times b. I'll need to divide 2 to both sides. That cancels out. -2 divided by 2, that's -1. This is b by itself. 16 divided by 2 is 8. On the left side, -1 is greater than or equal to b is also the same thing as b is less than or equal to -1. So I can just put a -1 here. It's all values -1 and less. On the right side, b is greater than or equal to 8. I can put 8 here. 8 is inclusive, and it shades to the right. Apply a test point just to make sure that your answers are correct. So test point, -2 is in the shaded region. I can put a test point of 9. We want to make sure that our answers are indeed the correct answers. 2 times -2 minus 7 is greater than or equal to 9. 2 times -2 is -4. -4 minus 7, -11. Absolute value of -11 is 11, which is indeed greater than or equal to 9. Going to test point number 9. 2 times 9 minus 7. 2 times 9 is 18. 18 minus 7, that's 11. Absolute value of 11 is 11, which is indeed greater than or equal to 9. So therefore, your solution will look like this. Onwards. Question number 22 from the book. Absolute value of 8 plus 4b is greater than or equal to 0. 8 plus 4b must be greater than or equal to 0. Now for this one, the fact that we're working with the 0 at the origin, it's the center point. So it's not going to have two sides to the system, it's only going to have one, because the absolute value of 0 will just be 0. There's no distance from 0 to 0. So all we need to do is just drop out the absolute value and then just work with the system. Subtract 8 to both sides. 4b is greater than or equal to negative 8. Divide 4 to both sides. Negative 8 divided by 4 is negative 2. You can draw a number line just to confirm that your answers are correct. That's negative 2. B is greater than or equal to negative 2. This is inclusive, and it points to the right. I'm going to apply a test point of 0. Eight plus 4 times 0, so I'm replacing b in for 0. 4 times 0 is 0. 8. The absolute value of 8 is 8, which is indeed greater than or equal to 0. So therefore, b is greater than or equal to negative 2 is your correct answer. Onwards. Question number 24 reads absolute value of 11 minus 2b minus 6 is greater than 11. Just in the previous questions, we were working on absolute values and the equations. We cannot work with the absolute values yet until we get everything else that's outside, such as the negative 6, pushed away to the other side of the system. So I'm going to add 6 to both sides first. (11 plus 6 is 17. From here, the absolute value is by itself, so I'm going to split it up. In this case, 11 minus 2b is greater than 17. But it should also have the other side if we're going to split up the absolute value. So we have the negative side and we have the positive side. From here, it's just regular computation, so I'm going to subtract 11 to both sides. Negative 17 minus 11, that's negative 28. So negative 2b. 17 minus 11 is 6. You want to be very careful about this next step. That cancels out. Negative 28 divided by negative 2 is 14. This is b. 6 divided by negative 2 is negative 3. Since we are dividing by a negative, the sign must change. So instead of greater than, we need to switch so it's the less than. Vice versa. If this is greater than, it should also be less than. And that's pretty much it. B is by itself. We can test to make sure that your solution is indeed the correct solution. The left side, that's the same thing. 14 is less than b is also the same thing as b is greater than 14. So I can put 14 here. It's exclusive, so it cannot touch 14, but it includes values above 14. On the right side, b is less than negative 3. I'm going to put negative 3 here, and it shades to the left. You can apply a test point. It's usually best to go 1 unit that's in the shaded region. So I'm going to test point negative 4, because negative 4 is right here. 11 minus 2 times negative 4 minus 6. Negative 2 times negative 4 is 8, positive. (11 plus 8 is 19. Absolute value of 19 is 19. 19 minus 6 is 13. And 13 is greater than 11.